So what is entropy? So let's say we have a random variable y. Let's say this y is a class variable here, or the target variable. So y can take any values, right? Let's say we have k class classification, a multi-class classification problem. So we can have k different classes, right? So if that is the case, then let's say y has these values y1, y2 up to yk. Okay. In our example which we were doing, so there we were using the binary class classification problem where k equals to 2, because it was play tennis or not play tennis, right? Yes or no. So let us assume that we have k different classes in the class variable, and now entropy is defined like this. So entropy is defined by h of the random variable y. It is equal to a negative sign followed by the summation of I equals to 1 to k, that is all the classes, like probability of yi, that means the probability of all the classes, right, multiplied by log of probability of yi. Okay, so this is the formula for entropy. So what is probability of yi? Let's say we have k equals to 2. Let's say in our example we had k equals to 2. So it was a binary class classification problem. Then what will be this formula? It will be minus, let me write it in a step by step way. So 1 to 2, right? And probability of yi into log of probability of yi. So what is it? I'll just write it in the left hand side. So it is like this: probability of p of y, let's say yes, because we have two classes, yes and no, right? So y yes into log of probability of y yes minus, because this is, here is a minus present, right? Minus probability of y no into log of probability of y no. I'm not sure whether it is visible or not due to my picture, but I'll just repeat: minus probability of y yes into log of probability of y yes minus probability of y no into log of probability of y no, right? So in our example, let's do it by the example. In our example, what do we have here? You see how many no's are present, how many yeses are present. So we have 1 2 3 4 5 6 7 8 9. So 9 yes are present. 6 7 8 9. So out of 49 yes, then 5 no's are present, right? So what we can do is we can simply write here. So probability of y yes is, it is 9 by 14, right? You already know how probability is calculated. So it is minus 9 by 14 because we have 9 ESS out of 14 data, right? So 9 by 14 into log of 9 by 14 minus, what is the probability of no? It is obviously 5 by 14. So 5 by 14 into log of 5 by 14. So whatever the result is, that is the entropy of y here, right? So this is how entropy is calculated. Okay, entropy is always calculated in case of decision tree. It is always calculated on the target variable or the class variable. Remember this, right? So now you see this log present here. We normally take the log base 2. Okay, we also write it as lg. Okay, log, sorry, so lg is nothing but log base 2, right? So these all the calculations which I'll be doing in this decision tree, so I'll be using log base 2, remember that. Okay, so this is how entropy is calculated. So in the next video, maybe okay, let me just write the result here. So it will be 0.94. You can check it. Okay, you can do it on your own. So it will be 0.94. Okay, now what we'll do is we'll try to split the data set on the basis of any of the 4 features. Okay, so we'll first try to like split the data set, the entire 14 rows into different data set or different sub data sets depending on the 4 features. First we'll be dividing the data set on outlook, then we'll be dividing it on we'll be splitting it on temperature, then we'll be splitting it on humidity, then we'll be splitting it on windy. Okay, whichever data or whichever feature gives the maximum information gain, I will use that feature to split. Now I hope you did not understand anything, and that is very normal. So in the next video I'll be explaining the concept of information gain. Along with that I'll be finding the entropy of different features. Then we'll be using the information gain. So see you in the next video.